equals negative 3x squared plus 2x minus 1. We know from the previous chapter that this is quadratic because it has degree 2. Any polynomial with degree 2 is quadratic. Okay, but if you ask me to explain to you what I see, this is what I would explain. The function is called f. The independent variable is called x. And what is the pattern? Here it is. F of whatever equals negative 3 times whatever squared plus 2 times whatever minus 1. Why do I see this? Because if you tell me find f of 0, I put 0 here, 0 here, and 0 here. If you tell me find f of negative 1, then I put negative 1 here, negative 1 here, negative 1 here. Because that's the pattern. It will be negative 3 multiplied by 0 squared plus 2 multiplied by 0 minus 1. These are nothing, and I get negative 1. If you ask me to evaluate for negative 1, I'll say no problem. Plus 2 times negative 1 minus 1. And now I perform the operations in order of operations. I have negative 1 squared that I have to perform first. The power is first always. So it's 1 times negative 3 is negative 3. 2 times negative 1 is negative 2 and minus 1. They're all negative. I add them up. It's 6 with minus in front. What is the ordered pair I got in the first step? 0, negative 1. X is always first. Y is always second. What is the ordered pair I got for the second one? Can anyone give us the ordered pair for the second option?
It's negative 1, negative 6.
Perfect. Thank you very much. But now it gets more complicated, a little bit. Because if I ask you to find f of x plus h, that's the same pattern. This is x plus h. This is x plus h. This is x plus h. Which means, so do not confuse this. Even my calculus students say that this is f of x plus h. No. No. It's not. This is f evaluated when the inside, the independent variable is x plus h. So I have to follow the pattern. And the pattern is negative 3 in parentheses x plus h squared plus 2 in parentheses x plus h and minus 1. So once I understand the pattern and I'm able to evaluate for a number, I should be able to evaluate for anything because I know what the function is telling me. Again, the function says negative 3 times whatever squared plus 2 times whatever minus 1. That's what we established from the very beginning. But now I need to simplify this. I copy negative 3, and what does this equal to? And make me very proud, and be careful what you say. How many terms will you give me?
3.
Please. Thank you. Good. So please give me 3 terms, and they have to be in parentheses. Then the rest is nice. I have 2x plus 2h minus 1. But I need 3 terms here. And then we can look at the table for evaluating. So can anyone give us the inside?
X squared plus 2xh plus h squared.
Thank you. In case you're wondering why, I wanted to avoid any confusion. So now I distribute and I'm done. This you can say, can you put it as an ordered pair? Yes, I can even put this as an ordered pair if I want to. X plus h, comma, f of x plus h. Which is all this. Okay, so let's look at the table just to see how it works, and we can continue with other important information about functions. So let's look at 96 on page 232. And you've never stopped me, so I'm hoping that you're following, and if you have questions, you will stop me. So I'm going to copy this table. They're giving us -2, -1, 0, 1, and 2. And then here f of x and g of x. And we have 6, 3, -1, -4, and 0, and 0, 4, 1, -3, and -6. And I'm copying what they want us to evaluate. And they want us to evaluate the absolute value of f of 1 minus f of 0 minus the, I think it's the absolute value, yes. Yes, it is the absolute value. So then they want g of 1 squared. And they want plus g of 1 again. And plus, no, I think it's division symbol. So this is divided by f of -1 multiplied then by g of 2. Okay, my third device is hibernating and I couldn't just wake it up, but this is what I see here. When I printed it out, it's kind of faded, but I see g of 1 divided by. Correct me if I copied something else. So first of all, let's identify all these values. I copy the absolute value. How much is f of 1? And how do I read from the table? Of course, can anyone identify f of 1 and then f of 0 for us?
It's -4
Yes.
and -1.
Yes, f of 1 is -4 and f of 0 is -1. So f of 1 is -4 minus f of 0 is -1, so I have no choice but put in parentheses. So this is this, this is this. Minus g of 1. G of 1, I have to put in parentheses and square it. How much is g of 1 from the table?
-3.
Excellent, thank you very much. And then I copy it again, also in parentheses. I copy the division symbol. Now f of -1 we need.
3.
Very good, awesome. I don't need parentheses for 3. And then I have to multiply by g of 2. And because it's negative, I have to put in parentheses.
Go.
Is that okay? -6. Okay. So now, step by step, let's simplify and perform the operations in the correct order. So I see here that this is -1, the opposite of -1, which will be 1. Do we all agree with that? I'm assuming you agree. -4 plus 1, because this is positive now. So that will be the absolute value of -3. I copy the negative symbol. I look at this piece. Can anyone give us -3 squared? It is positive 9 with minus in front that I already copied. Now I have to put plus for now. These operations have to be performed from left to right. First, I have to divide -3 by 3. So when I divide -3 by 3, I get -1. So this operation is -1. I copy the positive symbol. In parentheses, I copy -1. And then I have to copy multiplication symbol, and in parentheses again, -6. Now I go back from the beginning. I see the negative 3 in absolute value is 3. Negative 9 cannot be changed. But at this point, I have to perform this multiplication. And when I multiply negative 1 by negative 3, I'm sorry, negative 1 by negative 6, I looked at this and I said negative 3. Negative 1 times negative 6, I get positive 6. So then I write positive 6. It happens that 3 plus 6 is 9 minus 9, and the answer is 0. So the operations have to be performed in the order of operations, slowly, step by step.
Did I change the 3 to a positive?
What change? This one?
No, down one. Like you got negative 3 at the beginning and then...
Right. So the absolute value of any number is a positive number because it's a distance.
Okay.
However, if I have this, that's a different story. Here I had plus. But negative 3 in absolute value is 3, but with minus in front would be negative 3. But other than that, if there is positive in front of an absolute value, the answer will always be positive. Any questions?
Nope.
Okay. The next step, and I'll stop because we have a little quiz for today, is to graph a piecewise defined function. And this is section 2.2. And I know we will need more than one example on this. So 2.2, more, they say, about functions. More about functions. Okay. So, piecewise defined functions. And you can say, what is this? It's a function defined in pieces. Here's an example. I don't know much about, I do my taxes with TurboTax. So I don't know much about the basic code and where the percentages change, but this is but the tax code is a piecewise defined function. I'm just making up numbers now. For example, for someone who has an income of, let's say, less than 50,000, the person pays, let's say, 5% in taxes. Between 50,000 and 100,000, I'm just making up numbers, the person pays 15% in taxes. For 100,000 to 300,000, the person pays 29% in taxes. This is a piecewise defined function. So for different values of x, a different outcome. Different values of x, different outcome. And we can go on forever. So a function can have, a piecewise defined function can have 2 branches, can have 3 branches, can have infinitely many branches. So let's look at one with 2 branches. Let's say 54, and then we'll stop. Page 251, and we have f of x, 6x minus 1 if x is less than 0, and 7x plus 3 if x is greater than or equal to 0. The problem is only asking us to evaluate. I'm going to move on and say graph the function. Because I know that any graph or any function requires the first step must be domain, the first step, every time I'm asked to graph a function, that first thought is domain, always. I will look at this and say, obviously this is this interval to the left of 0. This is to the right of 0 with a bracket 0 to infinity. And now I'm analyzing these and I can identify the domain. Can anyone give us the domain of this function? It has everything to the, so we are talking about this function, not this individual piece. This function is made of two pieces. So the function, the domain of this function is, we have everything to the left of 0, we have 0, and we have everything to the right of 0. So what do we conclude then about the domain of this function?
It's negative 1 sin x equals positive.
Great job. So nothing is missing. Obviously, this value is a very important value. It must be in the table at all times. Okay, next I would say, let me look and see the symbols. I see this symbol, parenthesis opening this way, at 0, and also at 0, a bracket opening this way. Right exactly under 0, I will copy exactly these two symbols. The parenthesis facing left and touching bracket facing right. These are immediately under 0, right under 0. I know you're going to say this is an overkill, and I would have to agree, but sometimes these branches may be twisted, may not be presented in the correct order. To the left of 0, I have 6x minus 1. That's the function I have to use to the left of 0. To the right of 0, I have to use 7x plus 3. I'm going to choose some values. Let's say negative 1, between negative infinity and 0, and I plug it in. So if you want to plug in negative 1 and tell me what answer you get for the output. Anyone? Anyone?
Negative 5.
Negative 7.
Good. Now I want to plug in 0. And you should say no. And I will have to agree with you. I am not allowed to plug in 0 here. I don't have the equal symbol here. I cannot have it in both. It will not be a function. But bear with me and you'll see what happens. So let's plug in 0 inside the parenthesis. Right inside here, I will put what? Very good. Right here inside the parenthesis. So please plug in 0 on the other side and tell me inside the bracket, what will you say? I have to write. Very good. Right here inside the bracket. And let's say 1 on this side, and please plug it in and tell me what you get. What do we get the output for 1 when we plug in 1? Very good. Let's graph the function. I'm gonna graph two different colors. One color to the left of 0 and the different color to the right of 0, so you understand that you cannot extend anything anywhere, and they cannot overlap. It will not be a function. First order pair I see is negative 1, negative 7. 1, 1, 2, 3, 4. 5, 6, 7. Here's the point of negative 5, negative 7. And the point 0, negative 1 is right here. What kind of point will that be? Because I'm not really allowed to plug in 0. Will it be a full point or an open point? Open point. I'm making it as big as possible so it's clearly oops, I kind of missed it. So it's understood that it's not part of the graph. I finished with the left-hand side of 0. Now the right hand side of 0 starts at 0, 3. 1, 2, 3. This is a full point because of the bracket. 0, 3 is a legitimate point. 0, -1 is not. This is at -1. And then 1, 0. I'm going to say it's up here. I didn't plan perfectly. So see, here's the graph. This is the graph of f of x. You understand that the red graph cannot be extended to the left? Not allowed. The right graph is from 0 to infinity. From 0 to infinity. The left graph, the left piece, is only from -infinity till 0. Can anyone identify the range of this function for us? Anyone? Anyone?
I'm sorry, I can't read the numbers on the.
Here they are.
Oh, -1 infinity. Okay, so it's negative infinity. So bracket -1. What is that? Oh. And union 3 to positive infinity.
Very good. Excellent.